All right, let's dive right in. Today, we're unpacking a really fascinating mystery. If you're the kind of person who just has to know how things work, you are in exactly the right place. We're looking at the centrifugal lock puzzle, sometimes called the spin lock. Now, from the outside, it looks incredibly simple, right? Just a couple of blocks of wood or plastic. But it hides a secret mechanism that will completely mess with your intuition when you first try to solve it. In this explainer, we're going to break down the physics of this puzzle, and you'll see how this simple little toy actually connects to some massive engineering marvels all around us. Picture this. Someone hands you this small toy. 2 solid blocks, a top plate, a bottom plate. The challenge? Just separate them. Sounds easy enough. But here's the catch. No matter how hard you physically pull on these blocks, they absolutely refuse to budge. You can twist them, yank them, pull with all your might. Nothing. They feel like they're glued solid. There's no visible latch, no secret button, and absolutely no keyhole. So how on earth do you open a lock without a key, and without just busting it open with brute force? Well, that is the exact riddle of the spin lock puzzle. Okay, let's dive into this. To solve the mystery of why we can't just rip these stubborn blocks apart, we have to look past the outside. I want you to conceptually X-ray this puzzle with me. Imagine we've got X-ray vision and we're peering straight through the solid material to the hidden mechanics inside. What you'd see is an incredibly clever yet beautifully simple internal locking mechanism hidden completely out of sight. The whole secret to why this thing won't open lies right there, in this invisible internal chamber. So, when this toy is just resting in your hands, gravity and the design of that internal chamber are basically teaming up against you. Inside this stepped puzzle, there are tiny metal pins, or sometimes small ball bearings, depending on the design. These little metal pieces are strategically placed right at the joint where the top block meets the bottom block. And because of exactly where they sit, they act as physical barriers. They literally mechanically jam the two pieces together. As long as those pins are just chilling in that joint, the two plates are 100% locked. In fact, pulling on them, that actually just wedges the pins in even tighter. Since there's obviously no keyhole, we can't use a physical key to push those metal pins out of the way. So what's the trick? Well, the secret is that the key isn't a physical object at all. The key is motion. To unlock this thing, you actually have to stop pulling. Instead, you lay the puzzle flat on a table and you spin it. Like really fast, like a top. I know, it sounds totally counterintuitive, right? Why would spinning something cause it to open when yanking it didn't do a thing? It all boils down to one very specific law of physics. And that law, my friends, is centrifugal force. When you put that toy down and give it a really good, rapid spin, you're introducing rotational motion. Centrifugal force is that outward force experienced by any object moving in a circular path. It pushes things aggressively away from the center of rotation. Just think about being on a playground merry-go-round. You know, the faster it spins, the more you feel like you're being thrown backward off the ride. That exact same powerful outward push is what's happening inside our little puzzle block right now. So the crucial point is how this force interacts with those hidden metal pins. Let's walk through the exact steps. First, when the toy's at rest, those pins are locking the joint. Then you give it that rapid spin, which whips up that strong outward centrifugal force inside the chamber. Step 3, that force physically shoves those hidden pins away from the center, sliding them outward into these little cavities built into the outer edges of the block. This completely disengages the lock. Finally, while it's still spinning, or even a second after it stops, you just lift the top block and boom, it easily opens up. The lock is literally defeated by motion. Now, figuring out a wooden puzzle is definitely a fun party trick. But here's where this explainer shifts gears. We're moving from a neat micro toy trick to some massive macro world realities. Because this exact same physics principle, using centrifugal force to engage or disengage a lock, is not just for games. This exact science powers machines we rely on every single day. It scales up dramatically to protect us, move us, and literally save our lives. Let's check out how this invisible force is working right now in the background of your daily routine. Our first incredible real-world application is sitting right there in your car. Literally every single time you buckle up, you're trusting a centrifugal locking system. Deep inside the retractor mechanism of your seatbelt is a safety device built on the exact same principles as our spin lock puzzle. It's brilliantly designed to know the difference between your normal everyday movements, like leaning forward to change the radio, and the violent, sudden forces of a crash. And it does all this without a single computer chip or electrical wire. Now, what's really interesting here is how the belt responds to different types of motion. Think about the everyday scenario. When you give the belt a slow pull to strap it across your chest, it easily extends out. The internal spool is just rotating slowly. But in the event of a sudden stop, a heavy brake, or a crash, that spool jerks violently. This high-speed rotation instantly triggers an internal centrifugal lock. It's just like the pins in our puzzle, but acting in reverse. The force throws a mechanism outward that instantly jams straight into the gear of the spool, deadlocking the belt in place and keeping you totally secure in your seat. All right, shifting from cars to building engineering, we find another absolutely critical safety application. I mean, imagine the terrifying scenario of riding up a high-rise and the elevator cable suddenly snaps, or a glitch causes the car to start free-falling. It's pretty much everyone's worst nightmare, right? But the reason this almost never ends in disaster in modern buildings is thanks to a brilliant mechanical device called an elevator overspeed governor. And guess what? It relies entirely on our puzzle's favorite physics trick. Here's how that elevator safety trigger works to stop a catastrophe. The governor is directly linked to the movement of the elevator car. If that car starts dropping at a dangerously high speed, it causes the governor's internal centrifugal weights to spin ridiculously fast. Just like spinning our wooden puzzle, this intense rotational force throws those internal weights sharply outward. That outward physical movement catches a latch, which automatically triggers massive emergency brakes that grip the elevator rails. It stops the car entirely mechanically, saving everyone inside in a split second. Let's pivot back to automotive engineering for a second, because centrifugal force isn't just used to stop things or lock them down. It's actually incredibly useful for getting vehicles moving in the first place. In things like motorcycles, go-karts, or even motorized lawnmowers, we use something called a centrifugal clutch. It's a super efficient way to connect a running engine to the wheels without the driver ever needing to manually press a clutch pedal. Let's break down how this driving mechanism works. When the engine is just sitting there idling at a low speed, the clutch pads are hugging the center. They aren't touching the outer drum that connects to the wheels. But the moment you hit the gas and engine speed increases, the central shaft spins faster. That intense spinning creates a powerful centrifugal force that physically shoves those heavy clutch pads outward, fighting against their internal springs. Once pushed out, those pads firmly grip the outer drum, locking the engine's power to the drivetrain and smoothly turning the wheels to drive you forward. Pretty clever, right? Finally, let's step out of the garage and into the very precise clinical world of medical science. Honestly, this might be the most vital application of outward rotational force we've talked about. In hospitals and labs everywhere, this exact principle is used to save lives on a microscopic level. The equipment they use takes the concept of spinning to such extreme speeds that it makes our little wooden puzzle look like it's completely standing still. And this brilliantly illustrates the sheer power of this force. In a medical lab centrifuge, the whole mechanism relies on extreme, high-speed spinning. When a vial of a patient's blood is placed inside and spun at thousands of revolutions per minute, that intense centrifugal force pushes the heavier, denser components of the liquid outward, straight to the bottom of the test tube. The result? It physically separates the heavier red blood cells from the lighter liquid plasma, perfectly prepping the sample for critical medical testing and analysis. So when we bring it all together and summarize everything we've covered in this explainer, the vast impact of this one simple force is honestly staggering. Just look at the incredible diversity. From auto safety, where it jams seatbelts on impact, to building engineering, where it triggers emergency elevator brakes, from clutches engaging engines, all the way to separating vital blood components in medical labs. The exact same outward-pushing mechanism, hidden inside a simple wooden toy puzzle, is doing heavy lifting across all these life-changing industries. It kind of makes you look at the world a little differently, doesn't it? The same physics hiding in a child's toy could be exact same physics catching a falling elevator or prepping a life-saving blood test. Centrifugal force is literally everywhere, once you know how to look for it. So I'm going to leave you with this final thought to ponder today. What other simple objects or everyday toys sitting around your house right now might be holding the secret mechanics to complex, world-changing engineering? Keep your eyes open, keep analyzing, and never, ever stop questioning how the world around you actually works.